All right, welcome back. The next part that affects how intense the sunlight is the time of the day. You probably have noticed that in the morning the sun is more well, it's less intense, a little more spread out, and in the evening it's a little more spread out. But in the middle of the day, noontime, the sun is pretty direct. Especially, I notice this the most during summertime because we're not in school. I have a chance to work outside or be outside or hike outside or camp outside. So I try to spend as much time as I can during the summer being outside. And one thing I've definitely noticed throughout all my years of being outside is that if it's hot weather in the summertime, I like to sort of be finished with my most physical activities by 11 a.m. And then I might pick them up again like 3:30 or 4 o'clock. So for example, if I'm going to be hiking or backpacking or something, I'd rather get up early and knock a bunch of miles out and then take a big break in the middle of the day when it's really hot. And then once the sun starts to go down a little bit, it's getting towards like 4 o'clock p.m., I'll grab the pack and start crushing a few more miles before bedtime rather than trying to persist through the middle of the day because it takes too much energy out of me, because that sun is really so stinking high in the sky. It can really beat down on a person, especially if there's not a lot of shade around. So in the morning time, 9 a.m., sun's is not as high. Noon, then you can see where it's 3 p.m. here, it rises. In this case, it rose due east and set due west. So you know that this must be one of the equinox days. The angle of insolation changes in the course of one day. Maximum intensity occurs at noon. So there are little graphs showing the angle of insolation and the intensity of insolation. Looking south, we can see that the sun rises generally in the eastern sky. It sets generally in the western sky. It's going to make a big arc across the sky. Now, these shadows become really important because the Regents likes to ask about shadows. I'm not exactly sure why, but they do. I think it just shows that you understand the concept. So this is the shadow of the vertical pole. This is a pole in the ground. Indicates how the angle of insolation changes during the day. The higher or greater the angle of insolation, the shorter the shadow and the greater the intensity of insolation. So this diagram is fine. I think you can see it better off something like this. So in this thing here, this is our model. You can see the little man has a shadow here, a little woman, I can't tell, but the stick figure has a shadow. And what you'll notice is that throughout the course of the day, the shadow will change. This is actually changing throughout the course of the year. How did I get the day to go on this one? Bummer. I used to have one that had both. But you can even see here how the shadow, as the sun gets lower in the sky, the shadow gets longer or shorter. So when the shadow is high, when the sun is high in the sky, your shadow is shorter, and when it's lower in the sky, it is longer. So our shortest shadow of the entire year is going to happen at noontime on June 21st. And our longest shadow is going to happen sometime around like sunrise or sunset on December 21st. So when those days come around, you guys can run outside and take a look at your shadow. Like December 21st will be your next opportunity. As soon as that sun's coming up in the morning, run outside. It's your longest shadow of the year. You can't miss it. You don't want to miss it, or maybe you do. And then on June 21st, right around the time of the Regents exam, at noontime, you should take a break from eating your lunch and go outside and look at your shadow on the ground and say, that is my shortest shadow of the year. You can see it right here. It gets longer as the sun gets lower, and then it gets shorter as the sun gets higher. So sorry I can't show you the time of the day with this, but I'll find one that shows that probably when I get back to school. But this one at least shows you that you have a sinking sun, longer shadow, higher sun, shorter shadow. Okay. So we're going to do a little bit of practice with this. I'd like for you guys to get this sheet here from the front of the room. Okay, so this says Sun's Path in New York State. Okay, it's got a bunch of little things. So on here, they give you 3 paths, A, B, and C. And we want you to label which one the statement is referring to. So, for example, the first one says summertime path. A, B, or C? Summertime. Looking for a long one where the sun goes really high in the sky. I'm thinking that's C. Get the point? Okay, pause the video, go ahead and do this, and then we'll share our answers in just a moment. All right, hopefully you have had some time to go through this. So let's do it. Make sure you got the same answers that I did. The wintertime path is letter A. The spring and fall path, of course, is B. The sun rises south of east. So I see that happening right here. So my answer is A. The sun rises north of east. I see that happening right here. So path C is my best answer for that. The sun rises exactly east. B. The highest noontime sun. Well, that's going to be there. Path C. The lowest noontime sun is letter A. The longest shadow with the lowest angle of insolation. So remember, when we have a low angle of insolation, we're saying that the sun is low in the sky, and we're also we just talked about with the shadows being longer. Those occur when the sun is also lower. So we're looking at choice A for this one. The shortest noon shadow with the highest angle of insolation. This is going to be choice C. The longest amount of daylight. Choice C. The shortest amount of daylight. Choice A. The sun sets south of west. That's happening right here. So this is choice A. The sun sets north of west. Right here. We're looking at C. The sun sets exactly west. It's going to be B. The sun is out for 9 hours and is approximately 17.5 degrees above the horizon. 9 hours seems like a short day. I'm going to go ahead and say it's path A. The sun is out for 12 hours and is about 41 degrees above the horizon. 12-hour day. Sounds like an equinox to me. Let's say that is path B. The sun is out for 15 hours and is about 64.5 degrees above the horizon. I'm going to call that path C. What direction do you look to see the noon sun? Well, we always are going to have to look to the south to see all three of these noon suns. What direction does the sun rise and set? Well, it rises generally in the east. And it generally sets in the west. What direction does your noontime shadow point? Well, if the sun is over here, your shadow is going to point this way because the sun's shining and casting a shadow on the opposite side of where it's shining. So I'm going to say that that shadow points north. Now your morning time shadow. So again, we're going to be rising in the east. The shadow is going to be cast to the west. Your evening time shadow, so this is going to be in the west, is going to cast to the east. From sunrise to noon, what happens to the size of your shadow? Well, remember, in the morning, our shadows are longer and they get shorter as you get towards noon, so it's going to go, it's going to be getting shorter. And from noon to sunset, what happens to the size of your shadow? They're getting longer. So from noon, they're short. To sunset, they're going to be getting longer. Hey, hopefully you got all these answers and most of them on your own. You can go ahead and put this in the box. And then what I would like you to do next is actually to click on the video from Homix. It's called Sun's Path, I think. Actually, let me pause. Let me get the correct title of the video. 1 second. Yes, it's called Sun's Path by Homix Earth Science Department. And it's right on Google Classroom here, right where in the places you are getting these videos. So I'd like for you to watch that right now as a way to recap everything we just went through here with the Sun's Path. And we're going to take a little bit of a deeper dive into seasons.